So the strategy design pattern is one of the core tenets of object-oriented programming. What it essentially allows you to do is it essentially allows you to swap out components and just plug new components in. So what we're going to do is we're going to refactor this simple game into using the strategy design pattern. So let's just look at the code. It's a very simple game. We have a warrior, he fights, the warrior has a weapon, the weapon has a sound it makes whenever it strikes. So as you can see here, each warrior gets a name and they each get a weapon. However, we're not really able to customize this weapon object very much, except that we're just able to say it plays some type of sound. Now, in real life, we probably want to have a separate weapon for a battle axe, or a separate weapon for a bow and arrow, or a separate weapon for a sword. And then each one can have unique characteristics. Each one could even have special methods, like the reload time for a bow and arrow would be longer than the reload time for a battle axe. And so by using strategy, we're able to swap in these different pieces of functionality without having to use if statements. If statements are bad, so you want to try and avoid them. So first thing we're going to do is we're going to make this weapon. We're going to make it into an interface. By making it into an interface, now we can no longer have things implemented in this class. So we're just going to comment them out now. But we are going to say that each method should be able to perform some type of strike. So each method should be able to do some type of strike. And in order to be a weapon, you have to have this method. So let's take a look here. Now this is good. We can no longer implement weapon directly. What we want to do is we need to create types of weapon. And like right here, we could say we could implement this class anonymously. But that's not what we want to do, because we want to be able to make reusable code that we can share across our entire application. So let's go ahead, we're going to make a new package. And this package is going to be called weapons. One thing to note in package design is that one theory of package design is that you want things to flow downward. So notice everything in this top layer uses things into lower packages. So things in weapons wouldn't necessarily be able to reference the game or reference the warrior. That way, you don't have those cross-cutting dependencies. So let's make bow and arrow. Great, and we can give this a public void strike. And we can come to the game, and now we can say, alright, I want a new bow and arrow. But it's not going to allow us to do that because it's not considered a weapon by the Java type system. It's only considered a weapon after we implement the weapon interface. Implements weapon. Great. Now we can see, hey, the Java type system does actually recognize this bow and arrow class as a weapon type. And if we go back to bow and arrow, you'll notice right here we have this little eye. And clicking on this eye will take us to the interface class. Also notice, a lot of times on implement methods you'll see @override. And this isn't essential. It's not allowed when implementing an interface. Alright. That's not essential. You'll see a lot of people do it as a double check, but it's not essential. So now the nice thing about being able to use strategy like this is that we automatically know. We don't have to ask the user for certain pieces of information. We can lock that information in. So we can say public bow and arrow, and we're going to have a name for the weapon just like before, and we're going to have a sound for the weapon just like before. However, now we can say, now we can just ask simply for the name of the weapon. Because we know the sound's always going to be whoosh. We don't have to ask the user for that piece of information. We can, but we don't have to. Using the this keyword right here just delineates this variable versus that variable. Oftentimes they'll have the same name. So if you want to use the variable inside the object, just use this inside of your method. Whoosh. Great, so now if we run this, we should see that we've got the exact, let's go ahead and put a name in for that weapon. And so once we run this, you should see that we have the exact same functionality that we had previously. And that's the point of refactoring. When you refactor, you don't want to change the functionality. You just want to change the code and make it look better. So now that we have the exact same functionality, now we can really extend this. So now we can make a soldier. Call this guy a soldier. And now a soldier's not going to have a bow and arrow. But what a soldier will have is a sword. As, of course, we're going to implement weapon. Great. And we'll do it just like before. We'll say sword. That name equals name. Oftentimes, in my coding in Java, just to be more efficient, I'll type out a variable even though it's not made yet, and then I'll just hit Alt-Enter on it, and I'll ask IntelliJ to create the field for me, so I don't have to do the extra typing. And I'll do the same thing with sound. Slice. Alt-Enter, create field, sound. In fact, on this one, let's make the swords implementation just a little bit different. So we're going to say string def format. This is just like the formatting in C. And we're going to say %s to represent a string. We're going to say sound, sound. So it's going to say slice, slice. All right, soldier. Soldier's not going to have a bow and arrow. He's going to have a sword. And this sword's name is going to be Excalibur. Now we'll say soldier. Strike. And let's see how this turns out. Slice, slice. So the soldier goes slice, slice. The archer goes whoosh. And so the reason why this is considered strategy is that if we look at the warrior, we're able to define one class for the warrior. And it doesn't matter what type of weapon we put in here, as long as it's a weapon. So we can substitute any weapon we want. We can put any weapon we want in there. We're not tied down to a very specific type. And so that's how you do the strategy design pattern in Java.